What's at the heart of a black hole? Let's explore the science behind the mystery.
Have you ever wondered what lies at the edge of our understanding of the universe? Imagine a place where gravity is so strong that nothing, not even light, can escape. This is a black hole, a region of space-time so dense that it warps the fabric of our universe. The term black hole itself was coined by physicist John Wheeler in 1967, but the idea had been around for centuries. Black holes are not just empty spaces, though. They are formed from the remnants of collapsed stars, their immense gravity pulling everything in and letting nothing out. Imagine a star, many times larger than our sun, collapsing in on itself. This collapse creates a point of infinite density, a singularity, around which a black hole forms. This intense gravity affects space-time in bizarre ways. It warps the fabric of space-time so much that time itself slows down as you approach a black hole. Think of a bowling ball placed on a trampoline. The bowling ball represents a black hole, and the trampoline represents space-time. The heavier the ball, the more the trampoline curves. The closer you get to a black hole, the slower time moves for you relative to someone farther away. It's a mind-bending concept, but it's a key part of understanding these cosmic enigmas. The most common way a black hole forms is through the death of a massive star. Stars are cosmic furnaces, fusing hydrogen into helium and releasing energy in the process. This energy creates outward pressure that balances the inward pull of gravity. However, this delicate balance cannot last forever. When a star runs out of fuel, the outward pressure from fusion stops. Gravity takes over, causing the star's core to collapse rapidly. If the star is massive enough, this collapse results in a supernova, a spectacular explosion that can outshine an entire galaxy. What's left behind is a core so dense that it collapses further, forming a black hole. Not all black holes are created equal. Some are stellar mass black holes formed from collapsed stars a few times the mass of our sun. Others are supermassive black holes, millions or even billions of times the mass of our sun, lurking at the centers of galaxies. The formation of supermassive black holes is still a mystery, but they play a crucial role in the evolution of galaxies. There may be other types of black holes too, such as intermediate mass black holes, but their existence is still debated. Black holes are often described by just their mass, spin, and charge, but they have a fascinating structure. The point of no return around a black hole is called the event horizon. Once you cross the event horizon, there's no going back. Not even light can escape the gravitational pull from beyond this point. At the very center of a black hole lies the singularity. This is a point of infinite density, where all the matter in the black hole is concentrated. Our current understanding of physics breaks down at the singularity, making it one of the most mysterious places in the universe. Surrounding many black holes, especially supermassive ones, is a swirling disk of gas and dust called the accretion disk. As material falls towards the black hole, it spins faster and faster, heating up to extremely high temperatures. This superheated material emits intense radiation, making the accretion disk one of the brightest objects in the universe. Black holes are not just cosmic oddities. They play a crucial role in the evolution of the universe, especially in the formation and growth of galaxies. Supermassive black holes in particular are found at the centers of most galaxies, including our own Milky Way. These gravitational giants influence the orbits of stars and gas clouds, shaping the structure of galaxies over billions of years. They also drive powerful jets of particles and radiation, influencing the surrounding intergalactic medium. In a sense, black holes are the architects of the universe we see today. The study of black holes can help us understand fundamental questions about gravity, the nature of space and time, and the evolution of the universe itself. They are cosmic laboratories that push the boundaries of our knowledge.
Thank you for watching. If you enjoyed exploring black holes with us, don't forget to like, subscribe, and hit the bell for more science wonders. Join us next time as we uncover more secrets of the universe.